Hello YouTubers and fellow hams. It's been a few days. I've been playing around a lot with the big Munster mag loop back there. And made some observations and done some testing, and I thought I'd put together a little video and talk about what I've discovered so far. Now first off, to get it out of the way, it's not an efficient antenna for transmitting. It's a great antenna for receiving. It's really sensitive, but it's not a great antenna for transmitting. It's known that even a larger loop, like a classic style loop that you'd have outside on these frequencies has efficiency in the single digits, 3, 4, 5% efficient. So this guy back here is probably 1 or 2% efficient, for transmitting. I'm pumping in 6 watts. I might only be getting a couple hundred milliwatts radiated power. So I'm not expecting it to be fantastic, but I was hoping for making that first contact. And I did. This was the second night that I had the antenna finished, and I was trying to call CQ. Let's have a look at that. I was just getting ready to do my first regularly scheduled night of CQs with the new loop, 430 or 630 meters. Sorry about the camera audio. I'm kind of pressed for time. It's coming up on 10 o'clock. I got 10 minutes. So I thought what I would do is show you how I tune it up, the loop, that is. So on the computer, I have the software running for the Mini VNA. This loop's bandwidth is very, very, very narrow. The lower frequencies, the more turns I've seen on mag loops, the narrower that Q or that bandwidth gets. So it's really important to get it precise. And I have got my radio set, and I'm going to zero beat the transmitter on the frequency that I want my carrier at. So I'm going to put the radio at 474.5, which is about where I want the carrier to be. In USB mode, that's where I want my carrier to be, 474.5. Now I've turned the volume up, and I'll use the spot button on the transmitter. Right there is zero beat. So the transmitter is now set to 474.5. And if I go back to CW mode, yep, that sounds about the right pitch that I want. Okay, so I'm transmitting at 474.5, so I need to get the SWR on the loop at the bare minimum for 474.5. You really need some kind of an antenna analyzer to tune this. It's so narrow. You can't do it by ear. SWR meters, you'd have to spend a lot of money to get one that works at this frequency range. If you got a bird watt meter, I think there's a slug that will go down to 500 kilohertz and it'll work down to 470. But it's a really expensive slug. I think it costs as much as the meter. I read that somewhere. I could be wrong. I could be completely off on that, but I know it's expensive. So you really need some kind of an antenna analyzer that can handle this frequency range. I'm using the Mini VNA, and I've got the loop hooked up to it right now, and I just scanned it, and right now my lowest SWR is at 474, but I want it at 474.5, so I'm going to put a marker there, and let's see, I need to come up in frequency a little bit, so I'm going to just barely twiddle the cap. So I want to go up in frequency, so I want less mesh, which means this has to go that way, so I want to turn this just slightly that way. I just turned that about 7 degrees, and then I'm going to come over to the computer and hit scan again, and oh, I hit it. I'll take a screenshot of this for you, but I actually hit it right where I want. 474.496 SWR is 1.39 to 1, so that's pretty good. So I'm ready to transmit. I need to hook the antenna back up to the transmitter now. And now that I've got the antenna tuned, I don't know if you heard that tone, but that was somebody doing JT9. Okay, one other thing I want to show you. I have the field strength meter sitting over there in the vicinity of the loop, so just a second. Now hopefully that is not too much out of focus. And you can see the meter. And it is slamming so hard against the side that I can hear it go tick, tick. So it's, I'm going to turn that down so I don't hurt my meter. So it's definitely radiating really well. Alright, now I know you can hear that because I got the volume cranked way up. That's a JT9 transmission. I don't know who it is. I haven't got the computer on to monitor it. I should probably do that. QRZ.com so I can look this call sign up if I don't recognize who it is. Yep, K9KFR. Okay. I am going to go ahead and I'm going to call CQ and we'll see what happens. Somebody's answering me. Hope you can hear that on the camera audio. About an S3. K9 BLI, he's across town. But hey, it's over the air. Okay. On the 559. You're yes. 5 2 9. I know where he's at, and he's off the side of the loop right now. Well, hey. Back to you. So I got my first contact on 630, even if it's a local guy. It's a contact that's over the air. I'm sending him a QSL card. So I was quite surprised. I was thrilled, actually, when K9BLI came back to me over the air. I mean, it's just across town. It's a local guy. But still, it's over the air. You know, I did make a contact over the air on that monstrosity back there. I'm still doing it. I'm still calling CQ every night at 10 p.m. local, which is 0200 UTC. I'm throwing out CQ for about 10 minutes and hoping to make a couple more on that antenna. But anyway, what I wanted to do was I wanted to talk about some things I observed with the antenna itself and measuring it and in operating CW on 630 meters. Let's start there, okay? I ran across some information over on NJD Technologies website. And here we are on his site. And he talks about what's going on 630 meters, what signal modes and where they sit and all that. But one thing that was really interesting to me was here when he's talking about CW, right there. Most CW occurs on the opposite passband used for other low bands, 40, 80, 160 meters. That means when in CW mode, you want to be listening in the upper sideband portion or passband, and you might have to select CW reversed or CW normal. Normal? That shouldn't be right. This should be CW reversed. I don't know why you'd pick normal. On their depending upon their receivers. So what he's talking about is normally with CW, you dial your VFO to the carrier frequency where you're going to transmit. Okay, let's say that I was going to transmit on 7.050 megahertz or 7050 kilohertz. I would dial my VFO to 7050. And if I'm in CW mode, my receiver is going to listen in the lower sideband, passband, 600 to 800 hertz down, which means it's going to shift my frequency up the VFO when I'm in receive mode, it's going to shift it up 600 to 800 hertz so that the receiver is hearing a carrier at 6050. If you were receiving on exactly the same frequency you're transmitting on, you'd be zero beated. So you wouldn't hear anything. If somebody came back to you on that frequency, you wouldn't hear a tone because you're listening zero beated to the same frequency you're transmitting on. So when you're in receive mode, your receiver shifts up 800 hertz or 600 hertz depending upon how you have it set, so that you can hear the BFO, beat frequency oscillator, beating with this guy's carrier 600 or 800 hertz down into the lower sideband passband. That's normal on most of the HF bands. Is your receiver will shift up, so you're listening in the lower sideband. I think that's right. Anyway, what he's saying here is that it's normal for people on 630 meters to listen in the upper sideband passband, meaning the receiver would have to shift down 600 to 800 hertz. And if you are in CW mode and you're in the normal CW mode and somebody's answering your CQ, they'll be on your carrier, but that would mean that you're listening up here where they're going to beat with your BFO down here, so you wouldn't hear them. So I don't know how many people are aware of that, and I don't know how broad that practice is, but that's kind of important. So I'm going to do some more research on that and see if everybody's on the same page there. If not, I could be calling CQ with my receiver in CW mode, and somebody could be answering me, and I wouldn't have a clue that they were, because they'd be in CW reversed or they'd be listening down. Yeah. So anyway, that's that. That's one thing I discovered with CW. The other thing I discovered, which was kind of interesting with the multi-turn loop back here, is its bandwidth is extremely narrow. Now I've noticed with mag loops in the past that the lower I go in frequency on a smaller loop, in other words, when the loop is small compared to the frequency you're on, like a 3-foot loop at 10 meters is going to have a different bandwidth from when you've got it tuned to 40 meters. And I've noticed that like down at 40 meters, the bandwidth gets narrower. Well, that effect is magnified here, where I've got about a 3.5-foot square loop, this big monster back here, down at 475 kilohertz with multiple turns. It's extremely narrow. So for comparison, let's take a look at, I did a scan with the Mini VNA of the SWR, which is the blue curve here. And that's on the 3-foot copper mag loop, which is back here. This one, with the white PVC pipe, okay? Now that's a fairly standard common mag loop. It's 3 foot in diameter. It's 1 turn of copper pipe with a small coupling loop that's 1/5 the size. Real common design, like the Alex loop, the Alpha loops. They're all built like that. And this is a scan of that loop. Now, what's interesting to note here is the bandwidth. Okay, I decided to put a couple of markers where the SWR reaches 3 to 1. All right, and that's what these are here, from 14,090,983 to 13,975,945, and that's, you know, where we're reaching 3 to 1 SWR. I figured that'd be a good bandwidth range to calculate. All right, so let's pull the calculator up, and let's take 14,090,983 minus 13,975,945. So we get an operational bandwidth between the points where it's 3 to 1 SWR of 115 kilohertz. Is that right? Yeah, 115,000 cycles. So that's our operational bandwidth of the 3-foot magnetic loop. Now let's take a look at the, yeah, that's the 630 meter loop. All right, so here I did the same thing, and I dropped markers where the SWR reached 3 to 1. And if we take a look at the bandwidth here, all right, so we've got 475,504 minus 474, 184. We got a bandwidth of just 1.3 kilohertz compared to 115 kilohertz on the 3-foot mag loop. So a much, much, much narrower bandwidth. I mean, that is narrow. That's not even as wide as the passband on your receiver. You know, if you got your receiver in upper sideband mode, the passband for the audio is 2.3 kilohertz. But with this mag loop back here, this big one, the bandwidth between the points where we're at 3 to 1 SWR is only 1.3 kilohertz. Just a bit more than half the passband of the receiver. So if you want to operate it at a 1-to-1 SWR, you're really getting really getting narrow. That adjustment's like that, you know what I mean? And it's extremely sensitive to adjust. Now the tuning capacitor I've got on there, if you recall from the last video, is that great big E.F. Johnson cap that has a worm gear drive for the adjustment knob. So you can barely adjust it. So yeah, it's extremely sensitive to tune. I can't imagine trying to tune it up with just a regular variable cap. Having that worm gear drive, I turn that knob just a few degrees and the frequency shifts by a couple hundred hertz, you know, so it's extraordinarily sensitive to tune. Yeah, anyway, I think that's about it. So I'm going to keep calling CQ on this beastie back here and try to get a couple more contacts in, but I really want to get more signal out there. As I said near the beginning of this vid, the efficiency on this guy is probably around 1 to 2%, or maybe even less. I'm probably only radiating a couple hundred milliwatts with 6 watts in. Enough to get me across town, and if propagation was really good, I might get a rare QSO with somebody further away. It's receiving fantastic. Here we go. I forgot to bring this up. Whisper. I did a Whisper reception for a couple hours around midnight, and those were the stations that I heard on this loop here inside the house. So, you know, up there into Vermont, that was about the furthest away. Out here into Maryland, near Washington, D.C. Down into North Carolina, over into Wisconsin. You know, these are the stations I heard on Whisper with it. So its reception capabilities are pretty good. It's being so sharp on the tuning, even though I'm close to the AM broadcast band, I don't have any energy from the AM broadcast band interfering with my receiver. I have that problem here. If I put my end-fed wire onto the Yaesu 817 and I try to listen on 630 meters, I'll have this constant sort of noise from the nearby AM broadcast stations. There's just so much energy in the air coming down that wire that it's overwhelming the RF front end of the 817, and I have to desense it to where it's useless as a receiver in order to get rid of that. But on this loop, because of that extremely narrow passband, it's like a great pre-selector for receiving. So if you had real estate and you had some kind of external transmitting antenna, something like this might even be and you were near a broadcast station, something like this might be a good receive antenna, using the other antenna as a transmit antenna, and then transmit receive switching between the two. So you know, that's a possibility there. It could still be useful for that. But anyway, what I'm going to do to try to get more signal out there now is the next step in this process for me for getting on 630 is I'm going to build a bucket variometer, and that will be the next video. I've already got all the parts, I've got the wire, and I've started drilling holes. So I might go down to the bench today and try to get that variometer built. And I'll talk all about it in the video, what it is, how it works, and what it does, and why it's needed. And hopefully it'll let me load up my end-fed wire, which again is not optimally configured for this band. You really want something vertical, but I have no supports. So I'm really fighting an uphill battle here, but I'm bound and determined to get something a little more workable so I can play more with my snazzy little 630 meter CW transmitter I designed. Okay, well anyway, till the next video. Hopefully it'll come sooner, maybe in a couple of days, maybe by the weekend. We'll see. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.